This is Bradley Thayer for CIS 156. Today we're doing a brief introduction into Python dictionaries and why do we need a dictionary. Well, let me set that up with a fairly simple example. When we have a dictionary, we want to associate keys and values. And what do we mean by keys and values? Well, just think about the more standard term and meaning for a dictionary. It's a book that defines a word. You give a word, it gives you back a definition. So if I say run, I would give you back move at a speed faster than a walk. Never having both or all the feet on the ground at the same time. But it also could have more than one value. In this case, there were two definitions when I looked it up. Pass or cause to pass quickly or smoothly in a particular direction. Two definitions, just to be clear about what I'm talking about. It's definition 1, definition 2. So if we go from the more standard meaning of dictionary and go back into programming, what do we have something we want to associate with something else, like a product? A company sells a product, and we want to know how many we have on the shelf. So we have product 1, and we have 100, and we need to be able to find out we have 100. Well, we can use these right here, the lists in Python. But to do so, we would have to look up, we say product 1. What index is product 1? We would find out that that's index 0, and then we'd have to go through to the product quantity list and then find 100. So do a lookup here, and then find the quantity by finding the index first. Perfectly fine to do that. It's just a little bit more programming and therefore slightly more error prone. I don't know if this is a Python term, but it's a term that I've used, so I'm just going to say it's my term. Parallel arrays, meaning like index 0 and index 0 match. Okay, another way we might do the same thing I just mentioned. Try to find the number of quantity for a product. Would be with what, again, I'm going to call a flat list. Okay, I'm going to say this is my term. It might be official, it might not be. This is just what I've called it over the years. A flat list, meaning that index 0 and index 1 belong to each other. 2 and 3 and 4 and 5 and so on. So I find what index product 1 is at, and then to get the quantity, I add 1. Again, perfectly fine, but potentially more error prone. So with the dictionary, I have a product 1, and you'll notice the syntax here with the curly braces, the string key, and here it doesn't, when you get to the value section, it doesn't really matter. Many data types are okay. So here, product 1 is associated with the quantity 100, product 2, 200, so forth. I can print from the dictionary product 1, convert it to a string since it's a number, and then print it off. And when I do that, I say, yeah, the quantity is 100. Okay. But as I mentioned with the words a minute ago, the definition for run had two definitions. Actually, it had 4, but I put 2 of them up there. All right. So I don't get too ahead of myself here. You can look up the keys in a dictionary. So I can say product keys, so I can see, remember this is key value, key and value. So I can look up all the keys, and these are the things I'm allowed to look up. Now that I've said that, let me jump back to the idea of what I can do to associate more than one value for a key. So here I've got a dog and I named it Scruff. And Scruff is a Corgi, and the Corgi breed is from the United Kingdom. And I have another dog named Ruff. Ruff is a Dachshund from Germany. These right here are tuples. So you notice it's a key, and this whole thing is a value. So I didn't have to put a number here or a string. I can put a tuple or a list. In this case, I chose a tuple because Scruff will always be a Corgi, and the Corgi will always be from the UK. And as you recall from a previous lesson, the tuple is immutable. You can't change it. This is data that is not supposed to be changed. Scruff is a Corgi from the UK. All right, I can add Fido to that dictionary, a Cocker Spaniel from the UK. And when I reprint it, you'll notice the second time here Fido is now in my dictionary. I can delete Scruff, and I should print. And now Scruff is not in the dictionary. Now what if I want to put data in here that is mutable? Let's say I want, instead of the country of origin, I want to put how many years old the dogs are. So I'm going to put 10 and 5. For the time being, I'm going to get rid of this for my example here. And again, I can print this just fine. Scruff is a Corgi that's 10. But if I want to say, okay, Scruff just had a birthday, I'm going to have a problem here. Made a mistake there. I want that to be 11. That'll be the problem because this tuple is immutable. All right. So instead of a tuple there, I'm going to use a list. So this is an example of when a tuple or a list are more appropriate. When you know you're not going to change data, or when you know you will, there's a possibility you will, you're going to use the list. The tuple protects the data that shouldn't be changed. But in this case, I want to be able to change the age of my dog, and you can see that I've done so. Now this example here does open up Corgi to be changed. And perhaps there are some things we can do more advanced to kind of protect that data field that shouldn't be changed. But in the meantime, just as a quick example, data you want to be able to change, you can use the list here. Data you don't want to be, you can use the tuple. But you can combine the tuple and the list with the dictionary, and you can hold more data values here. Okay. So that's a quick example of the Python dictionary while also incorporating what we already learned about tuples and lists. Thank you.